Let's talk about isotopes. Isotopes are atoms of a particular element with different numbers of neutrons. And remember, it's protons that define the element. So we identify elements by their atomic number. Remember, we call the atomic number Z, and the atomic number is the number of protons. That defines the element, and that does not change in an ordinary chemical reaction. Mass number, which is given the symbol A, is the number of protons plus neutrons of a particular isotope. Okay, so the atomic number is on the periodic table because that does not change for every element. But the mass number is not on the periodic table because the mass number is the number of protons plus neutrons for just one isotope of the element. And an element might have many isotopes, many naturally occurring isotopes. The number that's on the periodic table underneath the element symbol is an average atomic mass. Okay, so it is the average mass of all the naturally occurring isotopes of a particular element. And we can calculate that average atomic mass using isotopic data. Now I'm just going to go ahead and I'm going to make up some isotopic data. So this element does not exist. This is purely just to show you how to do an isotope calculation. So I like to start by making a data table. So I'm going to call this isotope X119, and we'll call this isotope X121. Okay, so our element is element X, and its first isotope has a mass number of 119, and its second isotope has a mass number of 121. Now, if both of these isotopes were equally abundant, so if they existed in nature in equal amounts, so a sample of X, element X, would have 50% of this isotope and 50% of this isotope, the way we would calculate the average mass is just by adding those two numbers together and dividing by 2, right? So the average atomic mass in that case would be 120 AMU. But let's imagine that our fictional element X does not have equally abundant isotopes. Let's say that the first one is 75% abundant. Okay, so if the first isotope is 75% abundant, what's the abundance of the second isotope? Remember, the percentages must add up to 100%, right? So the second one must be 25% abundant. Okay, and then the next column in my table is going to be atomic mass units. So what is the mass of each of those isotopes? So let's say that this one is 119.123 AMU, and this one is 120.995 AMU. Okay, so this is our isotopic data. This is our isotope, this is its percent abundance, and this is its mass. Okay, and then the same for the second one. So what I do when I do an isotope calculation is I say the words as I do the math. So for example, I say 75% of 119.123 is, and then 25% of 120.995 is. Because effectively what we're doing, we can't just go ahead and add the two masses together and divide by 2 because we have to weight their masses according to their relative abundance. And we weight the masses by multiplying by the percentage, right? 75% of the mass comes from this isotope, while only 25% of the mass comes from this isotope. Okay, so percent means divided by 100. Of is a multiplication, so if we go ahead and we plug that into our calculator, I'm going to go ahead and do that right now. We've got 75 divided by 100 multiplied by 119.123 equals, and I'm going to write down the whole number, we'll talk about rounding in a minute, 89.34225. You see that? And then this one, we'll do 25 divided by 100 multiplied by 120.995 is 30.24875. Okay, so this is the mass contribution from the first isotope, and this is the mass contribution from the second isotope, and so we just go ahead and we add those two masses together. Okay, so plus 89.34225, and we get 119.59100. Okay, so before we round, let's see if that makes sense. Remember, we've got two isotopes, and this one, 119, is more dominant because it's 75% abundant than 121, which is only 25% abundant. So we'd expect the mass to be skewed towards 119, and it is. It's 119.59, so that's reasonable. Okay, let's talk about rounding. Both the percentage and the mass are measured numbers, so we do have to count the sig figs in both of those numbers. This has 4, this has 6, so our answer should be rounded to 4. This has 4, this has 6, so again our answer should be rounded to 4. And I mean 4 sig figs, I don't mean the number 4, that's just a coincidence. Now when we add, we count decimal places. This has something in the hundredths column. This is the hundredths column, so we need to round to the hundredths column. Remember, you can draw a vertical line to help you see that. So the average atomic mass of our fictional element is 119.59 AMU.